Example 28. A student observes that the brighter the light shining on a set of solar cells, the higher the voltage output. She constructs a circuit to show how the solar cells could operate the motor-driven sunshade above a shop window. So we have in the circuit diagram solar cells, component X, a motor, and a power supply. First question, name component X. So component X, this one here, is a transistor. Next part, B. Explain how this circuit operates the motor of the sunshade when the sunlight has become sufficiently high, sufficiently bright. So your description, you could start off by pointing out that if the solar cell output is less than 0.7 volts, then the transistor will be off. And that means that because the transistor is part of the circuit with the motor, if this part here is off, then the circuit for the motor is not complete. So that would apply. If it's dark, then there will not be very much voltage produced by the solar cell, which would mean the transistor is off. Next part of your explanation, you could then explain what happens if the sunlight becomes brighter. And at that point, eventually the solar cell voltage would rise above 0.7 volts. And above 0.7 volts is enough to turn your transistor into a conductor. So the transistor would be on. That would complete the circuit for the motor, and obviously the motor would then be on and operate the sunshade. So the final answer I came up with looks like that. So then on to example 29. So over the page you have an electronic circuit used to give a warning, and this circuit also contains a transistor. But the first question here is, what causes the resistance of a thermistor to change? Now you might be tempted to write the word temperature in here, but it's actually asking you what will cause the resistance to change, and it would be a change in temperature would cause a change in resistance. If the temperature doesn't change, then the thermistor resistance would stay the same. State the function of the transistor in this circuit. At National 5, we always use transistors as an electronic switch. There are other uses of them, but this is how we use them in N5. Next part, explain how the circuit operates. So the first thing is you've got to realize that you're looking at a voltage divider with these two here connected in series. This resistor is really just to protect the transistor. It doesn't form a part of the logic of what's going on in the circuit. So the thermistor and the fixed resistor form a voltage divider. As the temperature increases, then the thermistor will have less resistance. Now that means that its voltage will reduce in the voltage divider. The fixed resistor resistance will stay the same, but this resistance will drop at high temperature. So this voltage on the thermistor will drop, which means that this voltage on the fixed resistor must increase. So that's what I've put in my solution. At higher temperatures, the thermistor resistance decreases. The voltage on the thermistor, therefore, also decreases. Because it's in a potential divider, that means that the voltage on the fixed resistor must increase, eventually above 0.7. And when that happens, it will switch the transistor on. And that, in turn, will complete the circuit for the lamp. So the lamp will come on. The last part says, could you suggest where we could use this circuit to give a warning? So basically, anything where you've got a temperature rise that you don't want. So you could use it as a warning light if an engine was getting too hot.